Hello guys, welcome to this video on complex numbers. Now, we use I to denote square root of minus 1, which is an imaginary number. Square root of minus 1 is an imaginary number. So, for us to make it easier to simplify, because square root of minus 1 cannot be simplified. So, for us to be able to solve equation that has something like square root of minus 4, we assign I to be square root of minus 1 so that we can be able to solve it. So if we have square root of minus 4, this is equal to 4 times minus 1. So we can take the square root of each of them. So we have square root of 4 times square root of minus 1. So square root of 4 is what? 2. And what is square root of minus 1? I. You can see now that we have been able to simplify it since you have assigned I to be square root of minus 1, which is an imaginary number. So let's say we also have square root of minus 12, and we want to simplify this. So square root of minus 12 is the same as 4 times 3 times minus 1. So taking square root of each of them, we have square root of 4 times square root of 3 times square root of minus 1. So square root of 4 is what? 2. Square root of 3. And square root of minus 1 is I. So the value of square root of minus 12 is 2 square root of 3i. So when solving complex numbers, always take note that I is equal to square root of minus 1. Complex number is a number that contains the real part and the imaginary parts. So when representing complex number, we use z is equal to a plus bi, where a is the real part and bi is the imaginary part. A is the real part and bi is the imaginary part. And a and b are real numbers. Real numbers. So for this imaginary part, what made it imaginary is the value is I. I is an imaginary number. So these parts became imaginary because of the value of I. So let's say we have z1 is equal to 5 plus 3i. This is the imaginary parts. Imaginary parts I. I'm using IP to represent imaginary part, and this is the real part. I'm using ROP to represent the real part. So let's take another example. Let's say we have Z5. We have 4 plus 0i. This is the real part, and this is the imaginary part. The imaginary part. So if you watch, going back to the representation of complex number, we use a plus bi. So if you look at this Z5, you see that a represents 4 and b represents 0, and we have I. So a and b are real numbers, but what makes this part an imaginary part is because of the value of I. I is an imaginary number. So now we'll be looking at the equality of complex numbers. When we say two or more complex numbers are equal, it means that, let's say we have z1 is equal to a plus bi and z2 is equal to c plus di. When we say that z1 is equal to z2, For Z1 to be equal to Z2, we say that A is equal to C and B is equal to D. Suppose we have equation, we have Z1 is equal to 5 plus 2I and Z2 is equal to A plus BI, and is given that Z1 is equal to Z2. So what does this mean? It means that A is equal to 5 and B is equal to 2, because for a complex number to be equal, it means that the imaginary parts of both of them are equal and the real part of both of them are equal.